for having us here. What do you need? Gummy bears? You said PBX is dead. You don't get a gummy bear from. Okay? No, sorry.
He doesn't say that.
He doesn't say that. And you want 2 for your friend also. Because it's you.
Thank you.
No? Yes? Okay. My name is Mathias Pasquay, and I will do this presentation together with Thomas. We thought a lot what we will do. He wanted some smaller letters with config examples and stuff. I wanted fancy big letters with great slides. And then we agreed we cannot agree. And we divided it up. I have 5 minutes, or 8, to entertain you, and then he will do the real stuff. Is this okay for you? Okay. There is a warning. There is a warning. It contains advertising. So my part contains 60 seconds of advertising. So enable your ad blocker. How can you enable your ad blocker? Do you know you're very technical people? What to do? Close your eyes. Who said that? Who said that? Ah. Everybody of you has a natural embedded ad blocker. Did you know that?
No, what? Did you say sorry?
Natural embedded ad blocker. You're almost like a computer protected by IP tables. Do you know IP tables? Who knows what IP tables is? Everybody. Somebody who does not know what IP tables is. Okay. This is also for you. This is you. Maybe. You have a lot of interfaces. You have different interfaces if you're a man or a woman and stuff like this, but we will not discuss this. We will skip it. Last time a guy at Google did this, and he was unemployed after that. Maybe you can remember. So we focus on the head. We focus on the head, and here you have the eyes, you have the ears, you have to just imagine them, you have a nose, you have the mouth. So this is your possible default configuration. I will explain it a little bit. This is the Mangle table. Everybody knows the Mangle table. You change packets that you receive and do something. It's directly connected to your imagination chain. So you hear something, you see something through the input interface, and then you change it. Depends on your mental health, how much you change. So you change something. And then you have an input for your eyes, stuff you don't want to see, and you have an input for your ears with stuff you don't want to hear. So this is the default configuration. I make a short example how this works. If my wife says, "Darling, we should," then the Mangle table says, "You have to." You have to. I know this. And then it goes to, let's say, one of the tables, and then I have drops there. I just drop it, drop it, drop it, drop it. Sometimes this does not work. I reject it. And I do a very fancy trick. I get the input from the ears, and I do the reject through the mouth. Can you imagine? Do this? No. Reject. So it's really good. This is very personal. Everybody has a very personal configuration. So if you want to add your or enable your ad blocker, you can change the default policy to drop for all your inputs. I will show you the example. Can you see the problem? Who sees the problem? Again? Sorry, I could not hear anything. Yes, that's good. Jogging hazard. This is very dangerous if you do it like this. Thank you. This is very dangerous. So there is a better ad blocker. You can enable it, and you can disable it by putting a drop in the first line for your eyes, and then again for your ears. So on the first position, on the first position. Then it's very tricky, because if you add it on the first position 2 times, you can also delete it from the first position, because 1, 2, and then you delete it again. And the order matters, really. So I can show you. I enable these 2 rules. So first the eyes, then the ears. You can see I can talk, I can breathe, even if I have a assistant. I could even eat while my ad blocker is enabled. And then a very important thing, first release the ears and then the eyes, because otherwise you will fall into a sec fault and your family gets a crash report. So this is something maybe for the dangerous demos. I don't do this, and this is how you could do it. So enable your ad blocker. Now maybe you learned something for your life. And now I do some advertising, but only very, very short. This is pascom. We create a PBX system. As you learned, we are dying.
We all are.
Yeah, we all die. And, but we have a lot of fun while dying, and customers are buying our products anyhow. So that's good. Yeah, you can give me a hand if you want. So if you're brave enough, you can join us, and you write an email to job@pascom.net. This was the short advertising. Our vision, so the introduction to the next part of the talk, is we wanted a dynamic distributed system like everybody. We wanted to rule the world with a very big cloud system, which is very cool and can do everything. So I think many of you want this, so I don't have to explain all the details here. But there is something special about us. We want also to put it on a small box. So the same technology on a small box in your office should have the same capabilities as the big fat cloud solution. And I think this is relatively unique. Why do we do this? Because we want to sell our product also to a customer who installs it on site in his office. So that's my short introduction. Thank you. And we will have the next part now.
Okay, you can hear me, yeah? Yes. Okay, my boss said I will have your attention when he's done. I hope that works. We'll see. Okay, so I want to introduce you to the Consul. Actually, I didn't see Simon's presentation before, but he solved a lot of problems that we solved also, very different way. But yeah, we will see that it's almost the same basic ideas that we have. So what is the Consul and why do we use it? That's directly from the Consul website, a very long sentence. I will just read it. Consul is a distributed, highly available, and data center-aware solution to connect and configure applications across dynamic distributed infrastructure. What it's doing? Somebody understands that?
It's a hash table.
It is a hash table, yeah. Maybe more. Somebody knows the Consul? Few people. We'll see. Okay, first, it can be a service registration and a mechanism to discover services. So means you can register a service into the Consul, and other clients can, of course, use this mechanism to discover, let's say, microservices or containers in your network. This is not unusual. You could use a database or Redis or whatever you want. But special about Consul is it has 2 standard interfaces, and one of those interfaces is DNS. So you can integrate it with 0 effort if you're able to do DNS queries. That means you can actually always query the Consul, even without any client interface. Okay, it was probably designed for microservices. We use it a little bit differently. For us, a service is a full PBX instance. That means 1 tenant in a cluster. Also, it can be 1 zip proxy or an entire database container. So we're not doing fine-grained services. We treat entire containers as a service. It can also do health checking. in combination with those registrations. That means if I put a service into it, it can continuously check the health of this service by doing a ping or calling some script, but also the other way around with a kind of a deadman switch. So the service needs to refresh its health actively against the console. Otherwise, Consul will remove the service from the directory, and so the service will not be reachable anymore, also via the DNS. Of course, this is not comparable to a fully IT health checking metric system, but that's not the goal of it. It can also be a KV store, a hash table. It's not Redis, but it has a few nice features. Especially it's hierarchical organized, so it has kind of folders and values. A value can have up to 512 kilobytes of data, and it's data agnostic, so it's basically stored as base 64. You can put binary into it, you can put JSON into it, it doesn't matter. What's nice is it has a few tools for helping you in synchronizing things. So you can say, I want to change a value, but only if nobody else changed it in the meantime, so index-based. You can have transactions, and you can even do distributed locking, and you can use it in example for doing leader election. So if you have a master-slave database, Postgres, something like that, you can use it for deciding who will be the master, who will be the slave. So that's a typical use case for this KV store. But of course, you can use it as generic KV store, not as fast as the Redis, but for a lot of purposes, it's probably good enough. And it can do events. Again, it's not RabbitMQ. It's also not MQTT, but you can use it to broadcast data amongst your services. And it can do more. You can also listen to service changes or KV changes. That means you can do HTTP long polling on the console, and you will be notified if a service comes up or shuts down, if a health check fails, or if somebody changes a KV entry, or if the leadership of some service changes. That means basically you have one backend, and you don't have to decide in your client applications between will I do an event-based architecture, or will I do a state-based architecture? That means if your service comes up, you can query a full table of data at once, but from that point in time, you can listen for changes with the same backend. That's very nice. Okay, then it's multi-data center aware. That means you can have multiple clusters of this service, and it distinguishes between different zones. One database is not replicated to the another data center, but if you do a query, you can query everything from the external data center. That means if you lose one data center, the other one will be autonomous, but of course you cannot reach the other services, but it's not that the entire cluster would fail. Then it has a little bit of security, which is important to us. So it can do encryption between those Consul agents. It's, I would not say proprietary, but it's a symmetric encryption, so it has a shared key between the different agents. For the clients, on the other hand, it's basic HTTPS up to client certificates if you want that. And now another difference to probably Redis, it has a token-based access control list. So you can say for each connecting client, how much data can it see? Can it see all the services, just a specific type of the services? Can it see all the KV entries or just a part of the KV entries? Okay, then, and that's really a key in our architecture, there is a tool from the same company called Consul template, and it can query a Consul instance, and then it can interpret a template and render that template into your file system. That means you could do kind of for each loop over all your, let's say, backend API servers and provisioning your Apache with it. If one of the API servers goes away, it will re-render that template and reloads the Apache. So basically what Simon tool does as well, but yeah, different tool, same purpose. Okay, what's nice about it, you just write this template, and whatever key value path you use in it, whatever service you use in it, it will automatically listen for changes in this part of the console and then it will re-render the affected file. And as a bonus, it can run a command, in example, reload the Apache config or notify the Kamailio. Okay, how are we actually using this stuff? Because that's just what Consul can do. In order to understand this, I need first to go a little bit into detail how our product is structured. So we have hosts, we have obviously PBX instances, interfaces, and somehow we need to deploy this stuff. What's a host? A host in our world could be a physical machine, like Mathias showed in his slide, a small metal box that I put on my wall. It can be, of course, and usually is a virtual machine, but it can also be an AMI instance at AWS. Each host runs exactly one Consul agent, and the agent could be in two different roles. It could be a server, or it could be a client. All services on this host talk to this agent, which will forward the traffic to the other Consul instances out there. And each of our services has a different auto-generated ACL policy, so to limit what a container can read out of the console. Okay, what's a PBX instance? PBX instance is actually relatively fat because we put everything into it that you need for running the phone system for one customer. So that means the asterisk, a chat service, CTI services, everything except the database, because we can share this amongst multiple instances or hosts. Each of those instances has a so-called instance name. We need it to route traffic into it. Could be HTTP traffic where we have the instance name somewhere in the URL. It could be an XMPP address where I have it as a domain. It can be LDAP where it's part of the routine of the LDAP. It could, of course, be the zip domain in case I want to route the zip traffic. So this is very important to us. It needs to be cluster-wide unique. Okay, then we have interface containers. That's where Kamailio comes into play. An interface in our world is a special container that has always two interfaces. One of them is always a physical interface on the host. So we're not doing Mac VLAN or something like that, except you dedicate one physical interface for routing traffic into your system. If you have multiple network zones, you set up multiple interfaces. If you have VMwares, of course, a physical interface is not really a physical interface. It can be a VLAN or something like that. Okay, so we use it primarily for separating network and security zones. We run Kamailio and RTP engine in it, if the customer enables it. We run provisioning services for hardware desktop phones in it. We use it as a reverse proxy for API access. We run it as an LDAP server. We do XMPP in it. We have VPN access. And all of these features are optional. So for each interface, you can configure what you want. Do I run zip over this line, or is it just management, or do I only do the routing, or is it just VPN, or everything at once? And now we come back to this image that Mathias also had in his slides. It's the smallest deployment that we have. How small it is, you can see just by looking at this Ethernet port. So it's really a small box, but that doesn't mean that the customer needs to miss some features. So already on this platform, we're doing things like pushing to the mobile phones, waking up the mobile phone registration less, pushing chat messages, all this kind of stuff that we did see in those cloud presentations before, because also the small 5 to 10 user customer needs this stuff nowadays. Also, if he runs it without the cloud. Especially in Germany, people like to own this stuff, to put it into some rack, to put it on the wall, buy it, but that doesn't mean that they need to miss TLS or Opus or push. Why? Okay, then let's go one step above. It will be a multi-host setup. Of course, in between you can have a VM or just more hardware if you have more end users. In a multi-host setup, you need at least 3 hosts, because that's the smallest deployment where you can have a Consul cluster. You could also have 5 or 7 or whatever you want. And for at least 3 hosts, you would run Consul in the server mode to constantly replicate the data. And then you can have as many additional hosts as you want, but they will run Consul only in the client mode. They see the same data, but they don't replicate the data, only on those 3 or 5 hosts per data center. Okay, and then each host can have as many interfaces and PBX instances as your hardware allows you. That means for smallest cluster, you have 3 hosts with each 1 interface maybe, and a couple of interfaces on it. In a bigger deployment, you have dedicated interface hosts and dedicated PBX hosts. Okay, important to know is that each host by default runs also a shared database container. We're using Postgres here. That means we're not doing a failover. We're not automatically moving something because, let's go back, you don't need that here, right? And also for medium-sized stuff, we can transfer one instance to another host by just doing a snapshot of the database scheme and roll it out on the other machine. That takes a couple of seconds. So also no really shared storage here, but of course that's much easier to maintain, and usually for our customers it's enough. Or like Simon said, that's a problem for another day. Okay, then you can scale it up to use multiple sites because of this feature of Consul to have multiple data centers. And even in this situation, you can route traffic from one interface in the one data center to a PBX instance in the other. Basically, you put the media gateway into the country where your customer is, and the PBX instance stays in the data center where the customer wants his data. Okay, and again, the outage of one DC does not affect instances in other data centers. That's very important and was a core requirement when we designed this. Okay, now how do we implement this and how do we use it in the Kamailio? So what do we actually store in the Consul and how do we do the SIP routing? Okay, in Consul, we don't store highly dynamic data. We could use Redis for this, or we can use our Postgres database. We use it actually for the configuration or management administrative data for our containers. So what is this interface doing? Is the SIP enabled, or is it a VPN? Is it a routing container? Is it an LDAP container? Whatever you want. Also in the key value tree, we store kind of shared folders so that we can share some amount of data between different instances if we need that, or between interfaces and instances. And we use this also for defining routing zones and to propagate state. Okay, and then of course we have services, like mentioned before. That's all the PBXs that are currently online, all the instances, all the interfaces, all the databases, all the hosts. And how are we using this? In Kamailio, actually, we don't use the HTTP interface of Consul. We just use DNS because that's very easy. In Kamailio, we can also use the DNS cache. And in Consul, you have here a distinguished top-level domain, which is customizable. So it usually is .consul. We call it .pascom here, obviously. Then comes the type of your container in our world. That's a PBX. Then is it a service or a node? And here comes the name of the instance, which can be a tag. In between, you could have the data center. So in which country is this instance? And basically, you just do this DNS query, and then you get the internal IP address in the cluster for this instance, and I can just forward the zip package. So that's that simple, no magic here. Then we use it also for static service configuration. This is, again, related to how we're treating containers. So when we start up a container, we check Consul, we run this Consul template, and we write a couple of configuration files. A config file for Kamailio, which is included with the settings. Do I want to have UDP, RTP on this instance, on this interface, or do I want to have TLS, SRTP? Is VPN allowed or is it not allowed? So the basic things. If you change one of those parameters, you need to reboot this container. So you will, again, lose your voice streams. So that's obviously not always the best choice. So there is a second level. That's dynamic service configuration. So for a lot of changes, we can do something without a downtime. You change the certificate mode, you go for Let's Encrypt, or you go back to bring your own, or for testing purposes, self-signed, whatever. You want to trace the traffic, so you give it a home URL or not. And that, again, can leverage this Consul template, and it would do something like this. It just sets something in an H table in Kamailio, or uses generically CamCMD. Okay, then of course you can turn on and off protocols dynamically. You can configure your DHCP server, whatever you need. Okay, and last but not least, we're using Prometheus. So good that Homer supports it now for collecting service metrics. And so for each starting, stopping instance and so on, we're also provisioning the Prometheus instance, also on the smallest box. Yeah. Thank you. That's basically the technical part. There are some minutes left. Yeah. Do you have some questions?
Yeah, thank you. Are there some questions?
Tori?
Just
1 second.
with regards to using Consul in the DNS interface, have you ever run into issues with Kamailio or any other service caching the DNS and preventing load balancing from happening?
No, we didn't run into DNS, but like you see, we don't have millions of customers. Okay. It can be thousands of customers, but we didn't run into those issues.
Any other question? Okay. So my question about this console, you kind of approached it and you said, but did you actually test it something else, or you kind of ended up trying first this one and it was a perfect fit for you, or there were other options you considered and you dismissed it for a reason or another?
Yeah, we looked at a lot of things. So as usually, we started out to look at Docker, we looked at Kubernetes, we looked at Mesos, we looked at just roll our own thing, just use a database like Postgres or Redis. But at the end of the day, it looked most suitable to us to use the console because it's very lightweight and it does exactly what we need.
Okay. Anyone else with a question around? If not, Tom, Mathias, thank you for the presentation.
Thanks for having us.